Let's do a practice problem where we go back and create the same envelope of portfolios that we did for Kellogg and ExxonMobil in videos 1 through 4 or sheet 2 stock of this file. So we'll see if we can get these same numbers using the matrices approach. After that, we'll go ahead and use a risk-free rate of 1% to add the capital allocation line tangent to the optimum risk portfolio. So the first thing we do in all of these portfolio problems is calculate the return for each stock for each period, calculate the average return for each stock, and calculate the excess return. If we get our dollar signs right, we can copy that formula for all the excess returns for all the stocks. So let's go ahead and label the returns and the excess returns and even the variance covariance matrix and paste transpose to get the labels there as well. Because our next step is to calculate the variance covariance matrix using this formula. On the excess returns multiplied by the excess returns divided by the number of rows in the excess returns. Be sure to Control Shift Enter, and if we had all 4 cells selected when we started, we'll get the variance of Kellogg, the variance of ExxonMobil, and then the covariance between the two. Our next step is to come up here and build out our weights table. So if we want to go from 0% to 10% and so on up to 100, since we only have 2 stocks, we can calculate the amount in ExxonMobil directly. The next thing to do is calculate the risk of that portfolio using the square root of matrix multiply of the weights and the variance covariance matrix against the transpose of the weights, and then close out our parentheses and Control Shift Enter. If we had locked those cells, then we could Control Shift Enter. We could copy down. Let's go check that. Looking at the correct weights and the covariance matrix. And now we can calculate the expected return of the portfolio using matrix multiply of the weights against the transpose of the returns. Control Shift Enter. Should have locked the returns. Control Shift Enter and copy down. We want to copy those values back here to stock 2 sheet. Paste them as values. Then we can measure the difference between what we got on stock 2 and what we got a moment ago. Copy that for both columns, and we got exactly the same answers. So we'll Alt-HEA to delete all that and go back to our solution. We could do labels and descriptions. For this chart, it's not required, but one that would be important would be to talk about the optimum risk portfolio. And let's just guess a number. Let's assume 45%. Notice that when I hit Tab, Excel filled in all the formulas just by copying down. It saw that all 11 of these were the same, and it took a guess and filled those in for me. At any rate, to find out what the optimum risk portfolio really is, we need to adjust these 2 numbers to maximize a Sharpe ratio. So we could do that. I think in the past we calculated a whole column of Sharpe ratios. For now, let's just do the Sharpe ratio of the optimum risk portfolio. Alt-HAR to align that to the right. Now the Sharpe ratio is given up here as the return minus the risk-free rate over the risk of the portfolio. So the return minus the risk-free rate over the risk of the portfolio. That's the Sharpe ratio for this mix. We want to find out what mix would maximize that. We'd like to use goal seek because it's simple, but we can't maximize things with goal seek. So let's go to data and solver, and let's reset everything. We want to maximize the Sharpe ratio by changing cells. Now in the past we were changing all three weights. There's really no need to change this weight. In fact, we have it in there as a formula anyway. So as long as we change this weight to maximize the Sharpe ratio, this one will follow. And we don't have any constraints at all because, again, we don't need to make sure these sum up to 100 because of how we wrote that formula as 1 minus that number. And we don't have any particular return in mind. We just want to find the one that maximizes the Sharpe ratio, so we'll hit solve. And it looks like about 37% in Kellogg and 63% in ExxonMobil maximizes the Sharpe ratio. So let's go ahead and put all this on a plot. We know that the risk-free asset risk is of course 0, and we were given that it was 1. The optimum risk portfolio, we just calculated the risk and the return. And then we have formulas up here for the extrapolation. So let's draw the chart before we extrapolate so we can remind ourselves what we're doing here. We don't really want to plot the optimum risk. Let me show you what would happen if we did. If we just went there and said insert, and we get this extra point up here for the optimum risk portfolio, and if we're using a line to connect these dots, then it really messes things up. So let's back off what we're plotting. But let's go ahead and throw that on the chart as a separate series. So I'll copy, choose the chart, HVT to get to, or HVS in this case, to get to paste special. Tell it that it's a new series with the categories in the first column and no names in the first row. And now we do get a dot up here for that optimum risk portfolio. So the theory is if we drew a line from the 1% through the dot would be tangent. The line would be tangent at that point. So let's go back and do the extrapolation. I want to extrapolate that line out to as far right as my rightmost blue point, which is just the maximum risk. Let me add some labels. Let me add some titles to the chart. So we want to draw that line that goes from 1% through the tangent point out to the maximum risk. So let's find the maximum risk. Using this formula. And let's find the corresponding return using this formula. Now we can copy these 6 points, HVS to paste special, new series, categories in the first column, and no series name. And now we have the capital allocation line that's tangent at the optimal risk portfolio.